All right, so our topic for today is experimental probability. All right, we call it experimental probability because this experiment has already been done, right? So they give you the probability of each event happening after they do the experiment. And so we make our assumptions or our calculations based off of the experiment that already took place. So let me show you an example of that. So here, let's say we have an experiment already taking place. Uh, People have already taken the probability of each day or traffic jam on each day on I-20. Okay, so this is already taking place. And based off of this information, we're going to answer the question that they ask us at the end, right? So the table shows the probability of a traffic jam on I-20. Okay, so obviously it has already taken place before on these specific days. All right, so what is the probability of having a traffic jam on Monday, Tuesday, or Wednesday? So when it comes to theoretical probability, we have to have the Monday, Tuesday, or Wednesday. We have to have those all added together. All right, we combine those 3 days to make up what we have as our answer. Okay, so whenever we see this, and let me turn on my pen here. Whenever we see this word or, we see this word or, okay, it's basically telling me I have to add those up. Because it can happen on Monday, it can happen on Tuesday, or it can happen on Wednesday. So let's look at this. Monday has 0.19, or I can just say 1900s, plus Tuesday has 2800s, and plus Wednesday, which is 1400s. So if I add these probabilities up, I would end up with, let's check. Now I can do this by hand or I can use a calculator. Of course, it doesn't matter. 0.19 plus 2800s plus 1400s would make 6100s. Okay, 6100s. This is my probability of having a traffic jam on Monday, Tuesday, or Wednesday. So it's pretty likely, right, that we'll have a traffic jam either one of those days. Now, I have to change this to a percent, write your answer as a percent. So I already have the decimal. All I do is just move this decimal 2 places, and this is 61%. Okay. Let's answer the second part. What would be the probability of a traffic jam on Tuesday or Thursday? So let's add Tuesday and Thursday together, right? And we have to write it as a percent as well. So we have 2800s on Tuesday. On Thursday, we have 1300s. And that would make 4100s. And this equals, if we change it to percent, 41%. So there's a 41% chance of having a traffic jam on Tuesday or Thursday. Okay, Tuesday or Thursday. All right, now let's use a similar type of problem. This time we're looking at a bullseye, right? So this experimental probability has already taken place, right? This was an experiment that they did, and they found out that the bullseye, there's 36 or a 36,000%, not percent, decimal probability of having bullseye, right? Then you have 0.297 chance of having an inner ring. Then you have outer ring. Then you have a miss, right? So you don't hit the bullseye or the target at all. So this asks what would be the probability of having a bullseye or the outer ring. So this is the bullseye, of course, and this is our outer ring. Okay, so what's the probability of hitting either one of those? Because we have our or, of course, so that means either one of them I can hit. So if I add these together, the bullseye is a very small percentage, right? So 0.036 plus the outer ring would be, that's almost a 50% chance, right? This would be 0.423. We add those together and we would get, let's